up, guys? I'm going to be talking about the physics of earthquakes, and my name is Allison Short for those who don't know. So I'm going to start by talking about the background and what exactly earthquakes are. And they happen when two plates of the earth slip past one another, and this happens because the edges of each plate is rough, so then they become stuck to each other, and as the rest of the plates move, it causes a quake, and the friction builds up between them. So the tectonic plates are actually large slabs of solid rocks, and they glide over Earth's mantle, which the mantle is the rocky inner layer above Earth's core. And these plates move by convection currents. So here is actually a map of all the tectonic plates, and you see the one in America goes from Alaska down to Canada, down to California, and then through Mexico. And as you can see, there's a lot of plates across here, and they're all of different sizes. There's not one size for each plate, and some of them look kind of funky. But then we move on to the next part of the section, which is where I talk about why the Earth shakes. And this happens because friction forms between the plates, which it eventually releases in a big ball of energy, and that forms seismic waves that are kind of like ripples in a pond across the Earth that shakes it. And that's how the Earth starts to shake, and that's why things get moved around, buildings fall, stuff like that. And so then, how do we measure quakes? Well, we measure them by the use of seismographs, which form seismograms, and these respond to quakes and detect small movements in the Earth. So here's actually a photo of a seismograph, and it shows the P and S waves that it forms, which the P and S waves are basically the shocks of the earthquake, which actually make the quakes happen. So this is what it looks like, and they're very, very accurate in telling the amount of magnitude the quakes have as well, because it can detect really small movements in the Earth. So then I'm going to be talking about the P and S waves specifically. So the P waves actually travel faster and shake the ground where you are first, and then the S waves follow and shake the ground as well. But if you're close to the earthquake, the P and S waves will come one right after the other, but if you're far away, there will be more time between the two. So it's kind of like a thunderstorm. So basically, if you're in the middle of the storm, you'll hear the thunder and see the lightning at the same time. But if you're farther away, you'll see the lightning strike, and then a few seconds after, you hear the thunder. So it kind of relates to that, with the idea that they happen right after each other, and it depends on location, the amount of time in between. So by looking at the amount of time between the P and S waves and a seismogram, scientists can tell exactly how far away the earthquakes were from that location, and it's pretty accurate. It just can't tell the exact direction, so it gives a general idea of where the earthquake specifically happened. So then we move on to some quick fun facts. So the largest recorded earthquake was actually in Chile, and it was with a magnitude of 9.5, which is really high on the scale. And then there are actually around 500,000 detectable earthquakes in the world each year, but only 100,000 of those can be felt, and about 100 of these can actually cause damage. So that's it for my presentation. I hope you guys enjoyed and learned a little bit about earthquakes, and stay safe out there.